Today I'd like to talk about simplifying fractions. The last video I did was on finding equivalent fractions. And if you remember, we said that this idea of equivalent meant the same as, that these fractions were equal. When we found equivalent fractions before, we found fractions with a greater numerator and denominator. So for instance, last time we started with 1/2, and we said 1/2 could be the same as 2/4. Notice that the numerator and denominator are larger than 1 and 2. It's an equivalent fraction. It is the exact same amount, but we're finding an equivalent fraction with a larger numerator and denominator. Not a larger portion, but just we've divided the whole into more parts. We did the same thing with, let's say, 1/4. We could multiply 1/4 times 2/2, and we could find an equivalent fraction, that was 2/8. This is the exact same amount, but we've taken the whole, and instead of having only 4 parts in the whole, now we have got 8 parts. We multiplied it by 2, we have 8 parts, so our 1/4 is now equal to 2/8. Same size whole, but we found a part that was equivalent where the numerator and denominator was larger. So we could find equivalent fractions by multiplying. This is a lesson from last week. This week, we want to find equivalent fractions again, but this time we're going to use division because we're going to simplify. In other words, we want to find an equivalent fraction that has a smaller numerator and denominator. And so in order to do that, we can divide. So let's say that Maria has 12 boxes of apricots, and she sells 10 of those boxes. So she sold 10/12 of those apricots. So let's take a look at a fraction here. Let's make a model of what this looks like. So here we have got, 6. So now I've divided this into 12 parts. So 10 of those 12 parts would look like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a model of 10/12. But I want to find now an equivalent fraction that has a smaller numerator and denominator. So before we were looking for larger numerator and denominator, now we're looking for smaller. So let's see if I can't make the same size shape. I'm going to divide this shape into the same amounts here. Let's see. Okay. Now what I want to do though is see, can I make a fraction, a model of a fraction, where I'm not dividing everything by 12ths? What would happen if I said, instead of dividing everything by 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, yeah. What if I did half as many? So I'm going to erase every other line, so I have half as many of these lines here. Now I've divided the same size object into 6 instead of 12. So let's find out how many 6 would be equal to 10/12. I could say, here's 1, 2, 3, 4, 5. 5 6 is equivalent to 10/12. So I can make a model to prove this. But one of the things that I could do also is to show this with division. Remember I said that I used half as many? Instead of putting all of these lines in, I have half as many lines. So what if I divided this by 2? I don't want as many pieces in my whole. I want half as many pieces. I'm not going to divide it by 1/2. But to get that, I'm dividing it by 2. So 10 divided by 2, well, that is 5. 12 divided by 2 is 6. And look at that. We have the exact same thing. So I can draw a model or I can divide. Notice, please, like when we did multiplication and we were finding fractions that were equivalent, where the numerator and denominator were a larger number. Remember, our rule for that was we had to multiply the numerator and denominator by the same number. Well, now we're doing the same thing, only instead of multiplying by the same number, the numerator and denominator must be divided by the same number. Both must be divided by 2. If I divide one of these by 1 and one of them by 2, this is not going to be an equivalent fraction. I've got to divide both by 2. And also, friends, please note that I can't just take any number and divide 10/12 by just any number. I know that 10 divided by 5 is 2, but I cannot equally do 12 divided by 5. I don't want a part of a number, like a decimal or another fraction. I want it to be able to completely divide evenly, and I can't do that. I also couldn't do 3/3 because while 12 divided by 3 is 4, 10 divided by 3 is not going to be, I can't do it evenly. So I can't use just any number. I've got to use a number when I'm dividing that can be divided equally by both the numerator and the denominator. So let's try another example here. All right. So let's say that we wanted to have 8/10. We have a pan of brownies, nice long pan of brownies, and it is divided into 10 pieces. So let's see, I've got there should be 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. And I want to use up 8 of the 10 pieces. That would be 1, 2, 3, 4, 5, 6, 7, 8. 1/10 each, 8/10. If I had the same pan of brownies, and this time I didn't divide them into 10 pieces, I didn't have 10 friends over, maybe I only had 5 friends over. So I can now say 1, 2, 3, 4, 5. Now I've got 1/5, 1/5, 1/5, 1/5, 1/5. Now I can say 1, 2, 3, 4, 5, 6, 7, 8/10 is the same as 1, 2, 3, 4, 4/5. These are equivalent amounts. And again, I could show with division. What did I do? Well, I had 8/10 and I just used half as many lines. So I divided by 2. Each of these numbers, 8 and 10, can evenly be divided by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. So you can see 4/5 is equivalent to 8/10. And I can't really get 4/5 any lower. There's no number that I could divide by both 4 and 5 where it is even. And so this is the simplest equivalent fraction that I can make that is the same as 8/10. Let's try another one here. Let's go back to our 12ths, and this time I want to find what is equivalent to, I'm going to come back actually here to this to this 10/12, because I want to show you something about simplifying. I'll draw a model just to show you. So now I've got 12 fairly even pieces here. I've divided this object into 12 even pieces, and again, I wanted to use 10. I used up 10 of these 12 pieces. Underneath here, remember last time I did this, I had a object, same size, but instead of being divided into 12ths, each of these is 1/12, they were divided into 6. And if you remember, I said 1, 2, 3, 4, 5, 6 is the same as 10/12. Let's try it here with thirds. Would I be able to make a fraction that was equivalent to 10/12 and 5/6 with thirds? Well, let's see. Here's 1/3, here's 2/3. This is more than 2/3. So I can't make this any smaller. But what happens if I changed my fraction a little bit? And what happens if I said that I only wanted to have I wanted to be able to use 1, 2, 3, 4, 5, 6, 7, 8/12 would be the same. Instead of 10/12, I'm going to do 8/12. 8/12 is the same as 4/6. Would it also be, look, it's also the same as 2/3. This would be the simplest form. These are the smallest numerator and denominator I can have that are equivalent to 8/12. You can see that they're all the same size, but what if we were just using division? How would we do this? Well, 8/12, if we divide both the numerator and the denominator by the same number, we're going to divide both by 2. 8 divided by 2 is 4. 12 divided by 2 is 6. That's how we got 4/6. But notice that I can divide both of these numbers, 4 and 6, by 2 again. 4 divided by 2 is 2, and 6 divided by 2 is 3. So these three fractions are all equivalent, and I'm simplifying the fraction by creating a fraction that's the same amount, but it's got a smaller numerator and a smaller denominator. So we call this that simplest form. I'm dividing until I can't divide the numerator and denominator by the same number anymore. Let's try another one here. we had 6/9? What do you think we could divide both 6 and 9 by in order to find an equivalent fraction where the numerator and denominator are less? So let me think. I'm going to start. I could try to start with 6. I can divide 6 divided by 6 is 1, but I cannot evenly divide 9 by 6. So I can't divide both by 6. We've been trying 2 a lot. Let's try 2. 6 divided by 2 is 4, but 9 divided by 2, I cannot do that equally. So this will not be an equivalent fraction. How about 3? Can I divide both 6 and 3 equally by 9? Well, 6 divided by 3 is 2. 9 divided by 3 is 3. Look at that. Now I have an equivalent fraction, and I have simplified this fraction. Same amount. If I have 6/9 of a pizza, and my husband, Mr. Macy, has 2/3 of a pizza, we ate the same amount. So I'm not changing the amount. I'm just changing the size of my numerator and denominator. I'm changing the size I'm changing how many parts there are to the whole. I'm not changing the size. So here are my pizzas, right? And this is a pizza cut into 9 pieces, right? 1/9, 2, 3, 4, 5, 6, 7, 8, 9/9. I'm having 6 of those pieces. 1, 2, 3, 4, 5, 6. Now if I take a pizza, and again, if I divide it into thirds, and I say 2/3, 1, 2, you can tell just by looking here, look, I've eaten the same amount. 2/3 is that same amount. Yeah, it's that same, and I probably have to go like this a little bit, but it's that same, it's the exact same amount. It's the exact same amount. All right? Now, if I've got 2/3, can I make that fraction any simpler? I can't. There's nothing I can divide 2 and 3 by to make that fraction simpler. All right, let's try another one. How about if we try 14/21? I have a book that's 21 pages long, and I read 14 of those pages. I read 14/21 of that book. What's another way I could say that? An equivalent fraction where the numerator and the denominator are smaller. So think about, what do you know can divide equally into both of these numbers? Could 2? 2 can divide into 14 equally, 7. But 21 is an odd number, so 2 cannot divide equally. Well, how about 3 then? What if I was to divide both of these by 3? Well, 14 divided by 3 won't work evenly. It'd have to be 15 divided by 3. It would work. 21 divided by 3 is 7, but it won't work here, so I cannot use 3s. I can't really use 4s, 5s, 6s, but what if I divide both the numerator and the denominator by 7? 14 divided by 7 is 2. 21 divided by 7 is 3. Now I have created an equivalent fraction. I divided both the numerator and the denominator by the same number. So I have to be able to know what each of these can be divided equally into. All right, so let's see if you can try this out. Let's see if you get this. If you have a piece of paper at home, you might want to try this out, or maybe you can do it mentally in your head. What if we were to have 12/16? could you find an equivalent fraction by simplifying? Remember, simplifying means that we are dividing the numerator and denominator by the same number. So our numerator and denominator are smaller numbers, same amount, just smaller numbers. Stop the video, see if you can figure out a simplified version of 12/16. Go. All right, if you've come back, let's try one together. I noticed 12 and 16 are both even numbers, and I know that I can always divide even numbers by 2. 12 divided by 2 is 6. 16 divided by 2 is 8. I found an equivalent fraction. Now, 6/8, is that the smallest I could make it? Could I simplify this fraction even more? What if I divided it by 2 again? 6 divided by 2 is 3. 8 divided by 2 is 4. I found another equivalent fraction. All 3 of these fractions are equivalent. But this is the simplest form because there is nothing I can divide 3 and 4 by. Both of those numbers to get my numerator and denominator smaller. Now to get 3/4 up here, I could have started just by dividing 12/16 by 4/4. 12 divided by 4 is 3, 16 divided by 4 is 4, and maybe you did that right away. Good for you, that's fine. Both of these 6/8, 3/4 are both examples of simplifying the fraction 12/16. How about if we try another one? What if we were to say 15/30? What would be a simpler fraction that would be equivalent to 15/30? Why don't you pause the video, try out a couple of different ideas, see if you can figure out how to simplify this fraction. Go. All right, I'm hoping you've tried it. You're back. Let's see, what could I divide both 15 and 30 by? Well, I can't divide 15 by 2. It's an odd number. But what about 3? Could I divide both 15 and 30 by 3? Sure. 15 divided by 3 is 5, and 30 divided by 3 is 10. So 15/30 is equivalent to 5/10. 5/10 is just a simpler version. I wonder if I could even make a simpler version. What would be another? Maybe you tried something else. Could you have tried dividing both of these by 5? Well, 15 divided by 5 is 3. 30 divided by 5 is 6. Oh, I found another equivalent fraction. Wow. Let's see if there's another one we could find. What if I divided both of these by 15? Could I do that? Let's see. 15 divided by 15 is 1. And 30 divided by 15 is 2. Wow. So 5/10, 3/6, 1/2, they are all equivalent to 15/30. They're all equivalent. I can divide both the numerator and denominator by the same number, and I'm getting the same amount. It's just that my numerator and denominator are less. Instead of dividing something into 30 pieces, I'm just dividing it into 10. It'll take 15 of my 30 pieces or 5 of my 10 pieces. It'll be the same exact amount. All right, I'm hoping you were able to find some ways to simplify that fraction. So again, when we are simplifying fractions, we are finding the equivalent fraction. or just using a division. But remember, we've got to divide both the numerator and denominator by the same number. And this is really, really important. If you don't do this, you don't find an equivalent fraction. All right, so try this out. Use some of the worksheets that are attached underneath this video to practice this concept of finding an equivalent fraction by simplifying using division.